So in this problem, we're told that two similar triangles have areas that have a ratio of 8 to 23. So if two triangles are similar, that means that the ratio of their parts is some ratio m to n, and the ratio of their corresponding areas is that ratio squared. So m squared to n squared. So if we take what we're given the ratio of 8 to 23, that is the ratio of their areas. And so what that means is if we want to find what the ratio of their parts is, we take the square root of each of those. Here we're working backwards, right? So 8 corresponds to m squared, so m is going to be the square root of 8. 23 corresponds to n squared, so n is going to be equivalent to the square root of 23. So when we look at this conversion factor here for parts, it's either going to be root 8 over root 23 if you're making the figure or finding the perimeter or the one-dimensional part of the smaller figure, or if it's the larger figure, if it's a number that needs to be larger, you're going to use the other side, the larger side over the smaller side, so root 23 over root 8. So here in this problem, what we're given is we're told that the larger triangle here has an altitude of 67.85, and we want to find what is the altitude of this smaller triangle. Well, since we're making it smaller, here's the ratio that we're going to use. So if we want to solve for A is going to be the square root of 8 over the square root of 23 times the original length here, the larger area or the larger altitude, 67.85. So the smaller altitude is going to equal that measure, and then it's just a matter of calculating this. And so when we calculate this, we'll take the square root of 8, divide by the square root of 23, and then we're multiplying that all by this 67.85, and that's going to give us our solution, which is 40.02 approximately. And so that would be the solution for this problem.